So lately I've been thinking, we've been interacting with the internet the exact same way for the last 50 years. And that's through the keyboard and the mouse. And sure, along the way we got the smartphone and the touchscreen. But did it really speed up how fast we interact with the internet? Not only that, the conventional ways that we interact with the internet today misses out on millions of people. Now I'm talking about people with motor disabilities, specifically affecting hand dexterity. But today, I'm here to talk about an application that I made with brain-computer interfaces to interact with a web browser using the brain. For this application, I used the Muse tool. It's not as intimidating as some of the other BCIs you might have seen on the internet, like Neuralink, that drill something into your head. Rather, this device uses electroencephalography, or EEG, to read your brain. Essentially, we're picking up on the electrical signals created by your neurons to basically decode what your brain is doing. So the main goal of my application is to scroll up and down a web page, as well as switch between tabs in a web browser. And we can do this by analyzing certain phenomena in EEG data and mapping it back to the keys on a keyboard. So, for example, I used eye blinks to switch between tabs, and I used a focus measure to measure whether or not someone wants to scroll up or down the screen. To extract the features that I needed from the EEG data, I used a method called power spectral density, which essentially decomposes the overall EEG signal into its basic frequency bands. And if you didn't know already, our brain waves are made up of a bunch of frequency bands. And these include alpha, beta, theta, and gamma, and delta. And they all reflect a specific phenomena in our brain. I specifically used two different bands. I used the alpha band and the delta band, as the alpha band best reflects concentration and focus. And as you get more focused, your alpha band actually decreases, and as you get more relaxed, your alpha band actually increases. And I use a delta band because it's been shown that your eye blinks actually originate from the delta frequency. Outside of the analysis methods I used, I also applied a notch filter at 60 Hz to eliminate any type of power line noise from the EEG data. Once the EEG data was pre-processed using the filters as well as the power spectral density function, I used the delta waves from both of the frontal electrodes on the Muse as they sit right above both of your eyeballs. And I also used the delta or the alpha metrics from the temporal electrodes on the Muse 2, as they're the closest to the parietal lobe as well as the occipital lobe, where the alpha waves actually originate the most. Now that we've covered the specifics of the program, here's the demo of the final application. So in this short clip, you'll see me switching between a few tabs using my eye blinks, as well as scrolling up and down a web page using concentration. So at this point, the scroll direction is set upwards. So until I blink with both my eyes again, the scroll direction will always be upwards. So right here, you'll see me blinking with both my eyes. So now the direction changes, the scroll direction changes from going up to down. That's all for this video. I hope you guys enjoyed, and I'll see you guys next time.